Thanks. We're going to our last speaker. Bear with me. We now 15 minutes to the end, but I want to invite Dr. Luke Mehlo, to talk about indigenous fish and their industrial potential, maybe hopefully in 10 minutes. Luke, welcome.
Hello everybody. My name is Luke. I describe myself as an agricultural private dancer. By that I mean I am a private agricultural consultant. Before that, I was with the Council for Scientific and Industrial Research as a principal researcher, and later on as a business development specialist. So briefly, I wanna go into the innovation space of neglected, crops and the opportunities, that are there. But I have a very little story, that I think deserves to be told 1,000 times. And this is my on the road to Damascus with neglected, crops. Around about 2010, we were the first group that came up, with a plant, that linked phenotype, to genetics, in crops. By that, I mean, we developed a sorghum plant, that had half its leaves white and then the other half, green. The white parts, of that plant were incapacitated as far as photosynthesis, is concerned. But then, this particular plant, it was business as usual. It yielded exactly the same amount of seed that a normal plant, would yield. So, the question there was that, how does such a crop compensate, for half of the leaves, that are incapacitated? And, that takes us, all the way back into the realm of why these neglected, crops are resilient, as far as drought, is concerned. They are resilient as far as, poor soils, are concerned. So we were very, very excited. And one day, I showed this particular plant, to my mother. She looked at it and I told her, that this work has been nominated, for achievement, of the year, in 2010, by the UN Food and Agriculture Organization. And, she told me right then and then that, this will not win it. And when I asked her why, her answer, to that, was a question to me to say, when are we going to eat this technology? So, that to me, really, really crystallizes, the challenges, with the neglected crops. First of all, they are not in the hands of the people, that want them. The second thing is that they have been neglected, commercially. So the demand side of things and the supply side of things is not there. And then thirdly, research in these crops, has lagged behind, all other crops. So if you take sorghum and finger millet, as an example, the genome sequence, for finger millet was only done recently, way after other cereals like rice, had already been sequenced. Yeah, so that is really the heart, of things as far as neglected, crops are. Once you neglect something, you are very likely, to forget. So this was, my entry point, into, these neglected crops. And the primary focus, of our work, was actually on sorghum and finger millet. As you might all know, that finger millet crops like finger millet and sorghum, they are nutritionally dense. They are resilient, to poor agronomic, conditions. They are very resilient, to drought. So these are really crops, that have got a lot of potential, to alleviate, food shortages, especially, in the future. So, our approach, to this, to the challenge of, these neglected crops is that, there are far too many challenges. So these challenges need to be approached in an integrated, value chain manner. So we need to approach, these challenges, in an integrated value chain, manner. So for sorghum and finger millet, there are quite a number, of products, that, we decided, to focus on as value chains. One of them was a bioethanol, production. The other one was human food. And then the other value chain is, on livestock, feed. But before then, we had to do quite a lot of research, on these crops. Because like I said, they've been neglected, for a very, very long time. So there hasn't been that much improvement, that has been done on them. But, if one looks at this critically, this is actually an advantage, because what it means is that, these particular plants, because they haven't been worked on extensively, they still have, what is called genetic plasticity. So in other words, there are so many traits one could actually explore within these genomes, of these plants. There is really an unlimited number of traits. So I just want to, go through just a few of those traits, that we have worked on, using technology such as conventional plant breeding and, your other technologies like, induced, mutations. So one of the things, that we did, with induced mutations, as you can see, there, with one germplasm, of sorghum, we could create, quite a number, close to about 10 new varieties, coming, from one, by merely doing, a simple, genetic engineering, induced mutation, experiment, on it. We came up with a number of varieties that have got very different phenotypes, very different functional properties, and also very, very different, grain, properties. And one of the grain properties was the issue of double grains, or larger sized, grains, in sorghum. And again, if you look at, this particular slide, you would see that, there are different grades, of those double grains, all the way from a single grain, semi-fused grain, to completely, detached grain. And that is a phenomenon called, penetrance, or the degree to which a particular trait genetically can express, itself. So we created, a lot of these varieties that have got new functional properties. So the second trait, that we develop is bed resistance in sorghum. Because one of the problems, with some of these grains, because they haven't been improved, is that, they suffer extensive bed damage, in the field, so birds also view the sorghum, as a food. So we developed one new variety, that has got on little sharp, items, that are on the grain, that actually protect the grain. When birds try to eat, this sorghum, they get poked, in the eyes or irritated in the eyes, and they don't eat, that particular grain. So that helps quite a lot in boosting, production or yield, per hectare of these, crops. So the plant that you see, on your left is an unimproved, sorghum, variety, and one on the extreme right, you can see is a very, very high yielding, and it's got, if you look very closely, it has got those sharp, awns, that protect it, against the bird damage. So the second, major breakthrough that we did as well was, to figure out how to grains, both sorghum and finger millet, because at the end of the day, when you talk about product development and we talk about processing, it has something to do with the chemical functional properties, of these, crops. So I would want to illustrate, this fact, by, highlighting two traits, that we worked on, changing, the protein, body structure of, of sorghum and finger millet and pearl millet. We did this through induced mutations again, and that improves digestibility, because one of the major problems, with sorghum and finger millet is that, they are relatively indigestible when people consume them. Then the next thing, that we also worked on was changing, the starch properties, of sorghum. As you can see, from this slide, again, starch bodies, when they are irregular, they pack, quite closely, and the starch is very, very hard. When they are very spherical, they leave a lot of air spaces around them, so they are softer and easier, to process. So this is another functional property, that we changed. So, and one of the other exciting, thing that came out of this work, is that, we also created new varieties that accumulated, a lot of anthocyanins, within, the grain, itself. And this was really, really a breakthrough, because this is one of the functional properties that is very, very beneficial, to health. And just to illustrate this, I would want, to highlight as well to you one of the most, primitive experiments, that we did, to show this, because we wanted to show this even to villagers that visually, this particular, crop has got benefits, to health. And one of these, varieties, was very, very good at purifying, even water that was contaminated with textile dyes. You can see that, in the picture, especially the variety that's right at the extreme right, it could purify water, completely eliminate, that blue dye that is used, for dyeing denims, in water. So this work was really, really key because, one of the companies in the US, called the Silver PALATE, they are the very first, in the world to take advantage of the nutritional properties, of sorghum, especially the fact that, these grains accumulate very high levels of anthocyanins, because they launched a brand, called GRAINBERRY. And the naming of this particular brand was very, very intentional, because they are comparing sorghum, to the berries, that we know very well that accumulate very high levels of anthocyanins. And what this product really illustrates is that on a gram per gram basis, sorghum actually has more anthocyanins and more antioxidant properties, than your blueberries, for instance. So it is actually a superfood, in a way. So what we also did, with the particular varieties, new varieties that we developed, we convened, some stakeholder workshops where we availed these materials, to villagers, to do food preparation with it, and to come up, with innovative, recipes. So they came together, about 99% of them was women, and only a few men, turned up, because they had that, there's gonna be, some food, from the women that were preparing this material. So, and these ladies came up with far too many, products, cakes, flowers, porridges, and infant, food. And this is taken, from the fact that, these particular grains used to be used, a long time ago for nursing, sick people that wouldn't want to eat, other, items, and they would be fed, porridges, that are made of this, and people would recover, much quicker, because they've got a lot of phytochemicals, that are very, good for health. So this again is another low-hanging fruit, that can be explored, industrially. We can do it, here in Africa. And this particular variety that was used by GRAINBERRY originated, from Ethiopia. So, and the other value chain, that we also explored is, can we manufacture commercial feed, for commercial, elite, livestock, from sorghum and finger millet. And again, I'm showing, this particular slides. These are some of my animals. And there's one particular goat in here, a male goat, that would fight, with some of my workers on a daily basis, because it wanted to be fed hay that is made, from finger millet. So, what I was saying was, the other value chain, that we explored, was utilizing, these neglected, crops, to manufacture commercial livestock feed for elite livestock. That is livestock, that are kept, like in intensive systems like your feedlots, for instance. Because if humans continue neglecting, these crops, continue forgetting, these crops, the least we can do is actually to feed them, to our livestock, that won't neglect them and that won't, forget them. This is something, that we have already done, and we have produced, very, very high nutritious food, from these neglected crops, for commercial livestock. Some of these animals, that you see, over here are some of livestock that we have experimented with that did very, very well. And some of them won competitions, at shows, like the Boran cattle, the Dopa, sheep. And then the last part, which is really, really exciting, we also are experimenting, with these neglected crops, to, produce alcohol. And very well, like the previous speakers, have said, Alcohol is a legal, drug that is used extensively in medicine, in cosmetics, in the manufacture of paints, in manufacture of thinners, in the manufacture of cosmetics, sanitizers, hand sanitizers, especially in the era, of COVID. And, and it is also used, for blending, gasoline. And one of the things, that actually came up, is that finger millet is actually far better, than maize. It's far better than sugarcane, for the production of alcohol. And it has been traditionally used, for brewing beer, really excellent, traditional beer. So we are pursuing, that value chain. But the most important thing we are doing, with that is that we are trying to make that value chain viable, because a lot of companies that are synthesizing bioethanol, from these crops, are facing viability issues.